Hello all, welcome to my channel. As promised, I'm back with another video on Databricks advanced concepts. The advanced concepts that we will go through in the upcoming two videos will be these. So we will have uh, things that we will discuss is jet order, liquid clustering, photon autoloader, change data feed, deletion vector, delta live tables, auto compaction, auto CDC, delta engine, dynamic partition override, ML flow, auto ML, AI Genie, AI gateway, dashboards, then lake bases, and the lake family as well. So let's get started. So before we start, one of the advanced concepts which is very much used in Databricks is called liquid clustering. So liquid clustering is a way. So before we go with liquid clustering, let's talk about something about the JED ordering because that is a precursor. So JED order is a clustering technique that is used for data skipping and avoiding full data scans. And JED order in Delta Lake is sort and a repeat repartition. So what JED ordering does is a way to linearize multi-dimensional data while representing spatial complexity proximity, sorry. So what this means is that, for example, let's say if we have a column, we have a table, and we want to store data in such a fashion that our data should be searchable based on two columns that we have, or maybe let's say we are doing operations based on those two columns. So now if we partition data, so we have, let's say only we are talking about two columns, but we can have more columns as well. So if we want to partition our data, or we have to have files present in such a way, file groupings done in such a way that when we want to skip, we skip the whole file for searching certain things. We should not be searching across the whole files every time. So that's what this JAD ordering uh, tries to achieve. So what it does is it tries to make all possible combination of our dimensions and arrange them into a single orderly line. So let's say if we have, what do we mean by single orderly line is, let's say, as I mentioned, we have, let's say, three columns. So those three columns becomes our three different dimensions. So we can't sort, let's say if we sort based on all three columns, to find out something is there or not. So we have to store all those three information. So the different dimensions that we have, we want to make it in one single line so that instead of hopping from one state to another state, we are able to search the whole thing in one go itself. So that's what this uh, JED ordering does. So to just give you an example in this, let's say if we have without JED ordering, if we have let's say we have three files, file 0, file 1, and file 2, and they have overlap between them. So for example, if this is the whole space of file which stores some ranges, some partition. So for example, let's say if we split this in four what you call uh, quadrants, we'll have 1, 2, 3, and 4. So 2 is also present in the other file. Like, so this is the file 1. So file 1, 2, and 3, they have overlapping data. That's how it's there. And then when we do a JED ordering, what we do is we try to put the content of those things in such a way that we don't have overlaps. So for example, let's say if we have to find one, as I mentioned, let's say file 0 had four quadrants, 1, 2, 3, 4, and data let's say we are searching for uh, 2. So we'll have to open this file to see whether it is present in here or not. We also have to open this file because that also falls in the same range. And maybe we have to open the file 2 as well because we don't know where the ranges end because we have overlap. So we might have to open all these files. But if we have when we do a JED order, we now have three files which do not intersect with each other. So let's say, and if this file's max and minimum is stored, so we know that okay, in this files whatever is there, I mean we can simply skip if it is not in the range. And same goes with other two files as well. So this is what JED ordering does, that it will uh, place the data in such a way that we are able to find the results in quick time. And this is the Z order curve that we have. So it starts with like it goes from one quadrant to other, then it will come diagonally, then it will go again, it will go right, then again it will go diagonally. So that way, so this curve or the zigzag path, that's why the name is in G order. So this G curve, which is the bounding box for the orange line, if you see, is spans across interlock. For example, if we split the files based on here, so this one segment becomes one G order, this one is another G order, this one is another, this one is another. So here, when we travel from this to this, we are actually going tracking one, two, and three, maybe three or four quadrants. So that's where this Z order fails, Z order performs bad, and that's why uh, liquid constring was built by Databricks and the Delta team. So what this does, it organizes data based on columns that we specify. It continuously optimizes the data layout as we write. It adapts to the query patterns without we have to do anything, and works seamlessly with Delta Lake table. So it is kind of a self-organizing mechanism. Traditional partitioning, this is different than traditional partitioning or hive style partitioning, where we have physical data split. What do we do is we store everything as a flat, and then we have metadata of these in a form which is suitable for liquid clustering. And when we store this data, this metadata along with the delta log, so that way, and we create a Z cube, which is an incremental cube that gets created every time we insert a new thing, so that we don't have to recompute, or we don't have to create the clustering for already seen data. So this allows us to work with large tables. If we have varied query patterns, or we have dynamic data distributions, this liquid clustering helps. But only challenge with liquid clustering is that it only works with Delta Lake as of now. It doesn't work with other Iceberg or other open table formats. So this is how, for example, and also Z order, sorry, unlike Z order, which uses G order space filling curve, this one, like the one that we have, is it uses Hilbert curve, which is another different what we call uh, a different space filling curve, which is more efficient than G order. And if you see in here, we start from, let's say, from this box. If we have to go to the next box, this quadrant, we only have to travel to one particular, let's say two boxes in this case. But where here we have to cross multiple multiple bounding boxes. So that's where Hilbert curve is something which gives more better performance than just G order. So those are two concepts which are there in Databricks. Then we have photon acceleration. So photon acceleration is nothing but an runtime engine built in C++ for Spark, which helps us in avoiding the issues that come because of the JVM, and also because it is written in C++, it can utilize hardware more efficiently. So all the transformation that we do in Spark do get executed on native runtime with SIMD vectorization and all the benefits of newer hardwares. So this is what photon acceleration means. And we have to pay extra money for this, because when we enable photon acceleration, the charges are slightly higher compared to normal OSS clusters that we have. Another concept that we have in Databricks is called autoloader. So autoloader is an cloud optimized cloud file source for Apache structure streaming. We can simply think of this like, so when we have Spark streaming, we have an option of continuously loading files from a particular location, right? So a same concept is used in Databricks to create an autoloader. So what it happens is you define a location where it will keep on monitoring any new files that come, and as soon as a new file arrives, it will simply process that and store it wherever, or do a processing of that file, and then wait for another file to come. So basically, uh, it as I mentioned, it is running as a cloud file source. So that's why we have to mention here format as a cloud file format. We mention the which types of file we are expecting, like JSON, CSV, or others, and then We can also use notification, or there are other mechanisms as well, but in general, notification is quite good. Notification, what we will do is it will, when something gets uploaded to an object storage, it will send a notification, it will go to a queue, and then this listing service will read that based on the message, and then it will process this. But while we have cloud files, we can directly read it as well. So that's how this autoloader works for uh, Databricks. We can simply think of this as a Spark streaming application running all the time. So here we have two modes. One is directly listing mode, where it will check periodically make a call to the object storage to see if there is any new files, or we have a file notification mode that I was discussing, where the object storage will send a notification to the service, and then it will detect, and files will be processed as they arrive. So this is what there are two different modes for autoloader. Then we have change data feed. So change data feed is what it captures is the changes that happen to a delta table, and only forward looking once enabled. So we cannot uh, what this means is CDA, means what it does, it will keep on monitoring the change that happens. Let's say if we update a row, we delete a row, so those changes will be captured. That's why insert, update, deletes are what is this manages, and it will apply those to the target system. So it is similar to a CDC, which happens in relational database. For example, let's say Debezium, or there are other tools which do allow us to track change data capture. This is concept is very similar, but only thing that changes here is CDC is done at a wall level, so write ahead log, but this happens at delta log. So, and that's why it is only for delta. So whenever we write or do an insert, update, or delete in a delta table, all the events are logged into the delta log, and that delta log, this CDF is what it streams that particular log that has been there to the other system, so that they can act upon it, and hence the synchronization and everything can be done. So this is what a change data feed means. And also it has declarative CDC pipelines as well. Deletion vector. So again, this is a concept which is of delta format. So what this means is that whenever we delete a row from a table which is hosted in delta, the actual file is not updated. Only a vector, which is a bitmap, gets updated. And during the read time, we read both the deletion vector as well as the file, and then just discard the rows which are there. So this allows us for faster writes, faster updates, and we don't have to keep on updating, or we don't have to keep on creating new smaller files. So that's what this deletion factor makes life easier. And to enable it, we have to set the TBL properties, saying that okay, delta enable deletion vector sets to true. Delta live table. So delta live tables are a way for us to store our data as tables, while delta live tables are a way to, sorry, delta table is a way for us to store our data, while delta live tables are a way for us to move this data within this table. So delta live table is basically based on two what you call mode. One is execution mode, where it runs always continuously, and then we have pipeline mode, which is for which environment it is running, development or production. So delta live table is a declarative framework which is designed to simplify the ETL process, or how we move the data from one table to another table. So this the delta live tables is a basic building block in Databricks. It has been used in other products as well as a base. So we will see that as well. And so, for example, Delta Live Table was also made open source, and it has been now contributed to Spark. So we can also have declarative pipelines built on this Delta Live Table itself. And it has following asset types like streaming table for append-only data sources, and we have materialized view and views that is used for intermediate transformations. So this was it for this video. We will connect on a new video where we will see other concepts which are there, advanced concepts which are there for database. Till the time, have a nice day. And if you like this video, do support the channel. Thanks.